Other elements that are concerned are in different areas of our life. Let's look at some more. Many elements are needed for good nutrition. Now, there's really only one that we need to take internally in the pure elemental state, and that's oxygen. However, several other ones are known as, they're in a form that has a plus or a minus charge. They're known as their ion form. And in their ion form, they can dissolve very well into water, and so they can get into our body. And these are found in compounds, but when they get into our body, they behave as independent elements. The warning I have is do not look at most of the nutritional elements as something you would take internally in their pure form. They go into our bodies in a compounded form, and the compound releases the elements as ions. So don't eat pure sodium, for example. No good. But in these ionic forms that we'll get into later in the course, we find these four to be very important: sodium, magnesium, potassium, calcium. You may have heard of these before. You eat a lot of sodium chloride, table salt. Even if you don't eat a lot, you do eat some. It is an absolute requirement. Do not take sodium out of your diet. Sodium is very important for nerve conduction. Magnesium is important. Potassium. You may have heard of calcium being important for strong bones and teeth, and so these are very important ones. Iron, Fe, is what makes our blood red. We have lots of blood. It's all very red, so we need lots of iron. And it's involved in oxygen transport. If we can't get those that oxygen from our lungs down to our little toes, then we are no good, and that's what iron is all about. Zinc is an important metal to be found in lots of biological processes. We've got iodine. Iodine deficiency in people's diets used to cause medical effects such as goiter, and these days we have iodized salt and tiny ways to get tiny amounts of iodine in our diet. Very critical to us. Chlorine is very important in our diet. We do not want to take chlorine gas in. It's chlorine in its ionic form. And then we have what I would call macronutrient elements. Elements that are in compounds that are used on large scale, like things we call carbohydrates and lipids and proteins and nucleic acids. And the elements carbon, nitrogen, phosphorus, and sulfur reasonably fall into that category. I would put oxygen in there as well once it gets inside of compounds. In addition to nutrients, we have elements that are involved in other processes. Precious metals. Some elements are known as being rare, but the precious metal ones are the ones that are very stable and rare, so you can find them in nature uncompounded, just by themselves. These include silver and gold. There's a gold rush because you can go and find gold just pure lying around. Very rare, and so very, very valuable. Silver is a little less rare, but still valuable. And palladium and platinum are a couple of other ones that are classic precious metals. These days we know a lot more about elements. We've isolated a lot more than when we first said what precious metals were. Colors don't line up, sorry. Precious metals are these ones right here. For example, if somebody gives you some iridium, I believe the price of iridium these days is well above the price of gold. So you want to stick that one in your pocket and not let it get away as well. Iridium is a very rare metal. We also have various elements that represent toxins, and they come into our life, and we should be aware of them. Heavy metal toxins are ones that substitute for zinc and iron and other metals that are biological metals, and they mess up biological processes, and they're very important. For example, barium. You do not want to take barium internally unless you know exactly what you're doing. Maybe a doctor would have you do that, because barium can substitute for calcium, and that would be a very strong toxin for your body. Cadmium, arsenic, both elements you may have heard of before. and they're both can be found in our lives, and they both represent strong toxins that we try to stay clear of. Our drinking water is analyzed for arsenic because that can be in the ground. Cadmium is showing up in industrial processes and even consumer products. The NiCad battery is probably going to be phased out if it's not being phased out already because of the cadmium that goes into landfills when NiCad batteries wear out. This list right here is very interesting, long history. We'll start with Hg mercury. Mercury can be isolated and is very useful for electrical switches and different things. Historically, a very interesting story related to mercury is its ability to clean felt hats used by haberdashers in Victorian England, and the term mad as a hatter springs from the fact that they poison themselves and it's a neurotoxin. Okay, so these applications of mercury have shown that it's a very strong toxin. Mercury has been dumped in places because it was used and discarded from industrial processes. There's a famous location on the Pacific Rim where the town's children were born with many birth defects before they figured out it was mercury dumped into the local ocean, that went through the food chain and got into the local shellfish. So mercury's got a long history. These days, mercury gets used in poorer regions where they want to isolate gold. It turns out that mercury will dissolve gold. Do not do this experiment. So it's used for the isolation of gold. But then the thing about mercury is that it's a liquid, and if you heat it up, and you do for the gold thing, you get lots of mercury vapor. You can breathe it in, and it's very dangerous. Mercury is prevalent enough so that we find it going into our atmosphere in great quantities. And probably the biggest culprit for that is good old-fashioned coal. We burn many tons of coal in this country to get our electricity and for heavy industry. And as that coal gets burned, there is a mercury impurity in much of the coal. And so we are putting mercury in our atmosphere. Very tiny amounts, but with so much coal, it shows up all over the world at the top of food chains. Basically, the lower organisms concentrate the mercury as they go through the food chain, and you get to higher organisms. If you buy a fishing license, it will likely warn you not to eat more than one meal of fish a week because of fears of mercury poisoning. So that one's got a long history. Tellurium, or thallium, has a history of a poison. Okay, a little in somebody's food every single day. Don't do that. Okay, but there have been historic cases. Lead has been a metal that's easy to isolate, easy to work with because it's so soft, very heavy, nice to make lead weights out of. And we even see it in modern day in our lead batteries. It's been very useful for battery and a few other things. Lead is a heavy metal that can be a neurotoxin. Lead is considered to be more troublesome than mercury for one reason. It happens to be one that accumulates. Mercury will flush out of your system, but lead will tend to accumulate. So there are very strict control these days over lead, and if you dispose of anything made of lead, it needs to be disposed of properly. Polonium, very toxic metal. One of the problems with polonium is that it's radioactive. Radioactive means it gives off high energy particles that can be harmful to human health. The interesting story, just not too many years ago, a reporter showed up in a London hospital with all kinds of symptoms of radiation poisoning, and nobody quite knew what was going on. But when they went to the authorities that were involved in international crime, and they recognized it as the classic way in which spies can knock off other spies. Put a little bit of polonium on something sharp, hit yourself and hit your enemy in the leg with that, and you give them polonium poisoning. So the reporter who had been reporting on the Russian government was believed to have been poisoned by polonium. Astatine, I'm not sure what that's been used for, if anything at all, but it certainly is a toxin. Now, in addition to the heavy metal toxins, radioactive toxins we'll put in a different group. And I'll say we're going to do a lab on this, so you need to know the information from the lab. But the three radioactive toxins I'll bring to your attention are uranium, you can't see it, it's down there, uranium, radium, and radon. All three elements show up actually in our life in small quantities, and we recognize them as a health hazard. They're hazards because they are radioactive. We'll get into this later. They give off high energy particles, and the high energy particles can be hazardous to human health. Radium can get in drinking water supplies, radon can get into the atmosphere, and we can breathe it. Oh, okay. There are many stories, interesting uses, and devilish purposes to which elements have put to for almost every element in the periodic table. There are books on this. If you look it up in the library, you'll find fascinating books on the elements. I would like you to know about the elements that I looked at in this lecture as a basis for some common elements that have properties that affect our lives.